Hello grade 9s. So this is our last lesson for chapter 7. We're looking at properties of polygons. So we are going to do an investigation. Again, this is something I would normally be doing on the board with you. I'm going to take a ruler and a protractor and I am going to connect the midpoints of each side to form a new polygon. So for example, in my triangle here, I'm going to measure the midpoint, measure the midpoint, measure the midpoint, connect those three, and I see that when I connect them, I end up with another triangle. Moving on to my pentagon, with my ruler, measure midpoint, measure the midpoint, measure the midpoint for all 5 sides, and I notice that when I connect my midpoints, indeed, I end up with another pentagon. So this is true for any number of sides. When I take the midpoints and connect, I see that for 8 sides, 9 sides, 10 sides, I end up with that same figure inside. So, when the midpoints of the sides of a polygon are joined, a new polygon with the same number of sides as the original is created. The segment that joins the midpoints of 2 adjacent sides is called a midsegment. So this line here connecting midpoint to midpoint, that's called a midsegment. This line here that's connecting this midpoint to this midpoint, that's a midsegment. There's another midsegment. There's another midsegment, etc. Let's look at some special properties of polygons. So, looking specifically at a triangle. A midsegment of a triangle will always be parallel to the opposite side. So, take the midpoint, connect, and these two sides will be parallel to each other. I could do that for any two sides. I could take the midpoint of this side, connect, and this midsegment would be parallel to this side, etc. For a quadrilateral, the midsegment of any quadrilateral, whether it's regular or irregular, here we have an irregular one. Notice all 4 sides are different in length. When I connect the midsegments, what happens is we end up with a parallelogram. This will always be true for every quadrilateral. A square, if I take the diagonals of a square and measure them, I discover that they are equal in length. And they bisect each other. They cut each other in half at 90 degrees. So those 4 angles there each measure 90 degrees. If I take a rhombus, recall a rhombus is a square that's on a tilt. So if I take a rhombus and construct the 2 diagonals, take my ruler and measure, I will discover that these 2 diagonals are not equal in length. They will never be equal in length unless it's a square. Okay, so for a rhombus, diagonals are not equal in length. However, they do bisect each other. So that means where they intersect, they cut each other in half. So this equals this piece equals this piece, and they do this at right angles. So again, I have 4 90-degree angles in here. Furthermore, they bisect the angles at the vertices. So those 2 are equal, and those 2 are equal, those 2 are equal, and those 2 are equal. So I have 4 equal angles. If I take a rectangle, draw my diagonals, I will discover that they are equal in length, and I again will discover that they bisect each other. However, it's not at 90 degrees, as you can see. If I take a parallelogram, which is a rectangle that's on a tilt, and measure those diagonals, I see that they are not equal to each other, but again, they bisect each other. And again, those angles there are not right angles. Okay. Diagonals of a kite. So here I have a kite. I see that when I construct my diagonals, they are perpendicular to each other. So they intersect at 90 degrees. They are not equal in length, and only one diagonal is bisected by the other. So here we can see that my shorter diagonal is bisected by the longer diagonal. An isosceles trapezoid. So what's an isosceles trapezoid first of all? So trapezoid means that one set of opposite sides are parallel to each other. The other 2 are not. For an isosceles trapezoid, my other 2 sides are equal in length. Okay? So the diagonals of this isosceles trapezoid will always be equal to each other in length. They will intersect each other to form two pairs of equal line segments. So this equals this equals this, but they do not bisect each other. Okay, again, taking a trapezoid does not have to be an isosceles trapezoid, any trapezoid at all. If I join the midpoints of the two non-parallel sides, so midpoint, midpoint, connect, what I end up with is with a third line, which is called the bimedian, and it will always be parallel to the two parallel sides. So now I have three parallel lines. Okay, and furthermore, the length of this bimedian is always going to be the average of these two lengths. So if I add these two sides together, divide by 2, it's going to give me this length right here. Okay, so let's look at an example. Example 1. Given an isosceles triangle, here's my isosceles triangle, angle ACB equals 110 degrees. There's angle ACB, there's my 110 degrees. Point D is the midpoint of AC, so there's point D. Point E is the midpoint of BC, there's E. So this length here has a length of 7 centimeters. I want you to find the length of AB and the measure of angle CDE. Well, so CDE is isosceles because these are midpoints, right? This is isosceles, this is a midpoint, so this equals this, which means I have now a smaller isosceles triangle within my bigger isosceles triangle. I know that this is 110 degrees. In total, I have 180 degrees. So 180 minus 110 divided by 2 will tell me what each of these angles measures. So each one of these angles measures 35 degrees. The mid-segment, DE, that's equal to half the base. Okay, so that means that DE equals 1/2 times AB. Move the 2 over by multiplying, and I get 2 times DE equals AB, so AB equals 14 centimeters. Example 2. Given trapezoid ABCD, I know that length AB equals AC, so these are each 5 centimeters, and CD is 12.5 centimeters. Furthermore, angle ABD, so this angle right here is 140 degrees. Now I've got this point X, which is the midpoint of BD, so that means this half equals this half. Point Z is the midpoint of AC, so that equals that. XY is parallel, there's XY is parallel to AC. So this is parallel to this. You can see I have the single chevron there, and these three are all equal in length, and I have the double chevrons, or all parallel, sorry, not equal, they are all parallel, and I have the double chevron to show that. Okay. So I'd like you to find angle BDC, so that angle that's marked right there. I'd like you to find the length of XY and the length of XZ. Okay, so first of all, I have parallel lines, AB and CD, which means this is a transversal, and I have a C pattern here. So 140 plus angle D has to equal 180 degrees. Subtract angle BDC is equal to 40 degrees. Next, I need to find the length of XY, this length here. Well, I have a parallelogram formed right here. There's my parallelogram. I know that because this is parallel to this, and this is parallel to this, which means we have a parallelogram. So, XY has to equal ZC. XY, I know this whole length is 5, so half of that will be 5 divided by 2, which means this also is 5 divided by 2, or 2.5. And then if we go back and we need to now find the length of our bimedian, I know that the bimedian equals the top plus the bottom divided by 2. So 5 plus 12.5 divided by 2 tells me that line segment XZ equals 8.75 centimeters. So for homework, I'd like you to look at the questions on page 401 and 414. If you have any questions, please reach out to me and I'll be happy to answer them for you. Have a good day.